I have 4 tutorials and very simple PyGames, which end up being quite a bit of code just to do simple things. And what that does is it really gives you an appreciation for the games that you play on a regular basis, how much code and how complex that they are. So I'm just going to go through, actually, Pong is like the classic game. So I think I'll start there and go through a little bit of Pong because that's the classic game. Because that's like one of the first video games back in the old, before Atari, they had Pong and before those things. So to do this, we have to download the PyGame library. So let's take a look at how we do that. I'm going to open up, get a new file. We'll just call it Pong1, Pong_1.py. When I'm working on tutorials and doing things like this, if the tutorial is part 1, I have a Pong1. If the tutorial is part 2, I have a Pong2. Why would I do that? Doesn't that seem a bit silly? What if Pong2 breaks? I can go back to Pong1 and see where I went wrong. So I'm keeping versions as I go, which when I designed the tutorial, guess what? That's what I did. Let me get back to here. So Pong has Pong1, Pong2, Pong3, Pong4. So if something went wrong as I was developing this, I could go back to one that I know works. So this does the playing surface. Then we draw the ball, then we move the ball, then we bounce the ball, then we have to get the paddles. You know, it's not as simple as you think. There we go. So Visual Studio Code, always, there we go. And yes, I do want to remember that. So sys is it just gives us a clean, it gives us exit. So the sys library is built into Python. This one is not. So there's 2 versions of PyGame. This is the PyGame Community Edition, which theoretically is updated more often than the other one. The regular PyGame, does it matter? No. They're drop-in replacements. This is more of an open source one. I don't know. This is just the one that I use. So we would have to install it, and quite often in these tutorials, I put in exactly the command to install that library. So I'm going to install that library so I can get my background going. So PIP. Oh, that was not what I copied, was it? PIP, and I think I selected it, but did not do anything else. So you can do just PyGame. I just have do PyGame-CE Community Edition for no reason other than that's what I do. Oh, it's already in there. Cool. Oh, but it's not up to date. There. -U allows us to update it. I know there was an update on it. Yep, there we go. So how do you find out if your libraries need to be updated? PIP list -O. I figure O is for out of date or old or something. That's how I remember that it's O. And this will go through and look at all your libraries and see which are old. And it takes a moment because I probably have a lot of libraries on here. Oh, look at that. See, all of these are old. Let's just say I want to update one that we've used, Rich. We've been using Rich. So when you installed it, it might have been at 14.1. Now it's at 14.2. So to update it, I would do PIP install Rich, just like I normally would install it. I add -U, but this is a capital U. And then it will update Rich to the latest version. Sometimes updating a library breaks other libraries, but quite often pip will say, oh no, you cannot do that. You have to use this version instead. Or requests, we use requests. So I can do the same thing for requests. Do you have to update all these? No. But if you had installed it from the beginning, you would have that newer version. Now, if you want to get rid of a library, let's see, we'll get rid of Paperclip. Well, we'll get rid of Rich because we can always install it again. Whoops, you have to type it right. Uninstall Rich. And there it is. It'll get rid of it for you. So if you have libraries you don't need, get rid of them. I do need that one for something, so I'm gonna keep it, but now I have PyGame installed. And then I import the PyGame library. I'm importing exit. At this point, as we go, we're going to turn this into an object-oriented program because when you get more complex programs, I think it's easier to organize things as classes. But right now, we don't know what a class is or an object or anything, so we just have from the top to the bottom. RGB, who knows what RGB means?
Red, green, blue.
Yep. And so how does RGB work?
So it uses basic red, green, and blue to make different other colors.
And what's the maximum? Isn't it 255 or 254?
Yeah, 55.
Yeah, 255. So 0 would mean there's no color, 255 would mean there's a lot. And so if I do 128, that means it's got 50% red. And I don't remember why I did this particular color. I just did. So that's going to be the background of my Palm game. Can you change that to whatever you want? You betcha. If you have a particular color that you like, you can say RGB color picker. Now, some of these sites will actually, you can type in the name. Let's see what we got here. Do I like yellow? No. So I think I'll do this. Do I like that? No, not particularly. There. Now there's a nice teal green kind of a thing. Does that look like a good background to you?
Nope.
Well, all we need is these three guys right here. That's the RGB values for this particular color. Maybe I want it a little darker. Oh, now we're talking. But you can adjust it up and down. So I'm going to take that and put it into my program. There. So now I have teal green or whatever that was. That's going to be my background. This is the original width and height for the original Palm game. I looked that up and I thought, oh, let's just go back to the basics, right? The original Palm game, way back when it was first invented, was this. We have to get the PyGame library running because PyGame is what's called a game engine. So a game engine. Oh. Let me find a little thing here. I have something somewhere. Let me find it. PyGame, I have a little picture of what game engines do. There we go, bouncing. That might be it, bouncing bubbles. Yeah, there it is. Here's some of the explanations of stuff. So what is PyGame? It's a 2D game engine. That's what PyGame is. And here's how we already went through that. Oh, by the way, if you want to know Cougar Gold and Cougar Blue, there they are. One of my things that I have. So Cougar Gold, this is the official. Cougar Gold is 249,190. That's the official Cougar Gold. And Cougar Blue is 058,112. That's the official RGB values for WNCC. And many companies will have, like Microsoft or whatever, Google will say, the Microsoft Blue is this. So nobody uses a different color blue, which is the idea of this. If anybody does anything for WNCC, they're supposed to use that color. That makes all your marketing and everything consistent, which makes sense. Yeah.
So things like that, can they be trademarked or is it not really that?
I don't know that you can, I don't know. That's a good question. Trademark. I don't know. I used to know more about it back when I was working for a company. Yeah, I don't know. I don't think you can trademark color. I don't know. That's a good question.
I think the logo,
A logo can be trademarked. Yeah,
like, I don't think the color, because
No, I think you can, because I think.
I think the logo and the color.
T-Mobile, I think, has a trademarked color.
Okay,
Like, yeah,
that could be. I used to know more about it years ago, but I don't know anymore. Because we did some trademarking of Central Vac International. This is a company I did work for like 40 years ago, and they still have my stuff on their website. So I must have done a good job, right? It's still there. So this is their new logo. We copyrighted and trademarked it or whatever you need to do to copyright that particular look. And if you ever go to centralvac.com and you want to see some of the things that I did, DIY, there I am. No, I'm not actually there, but there's my installation guide. Pretty much, that's pretty much how it. They changed a few things, but you know, I did all this years ago.
It's cool.
Still holds up, doesn't it? Just like Van Gogh, that's what I figured.
Yeah.
I did the operations manual, I did a whole bunch of stuff.
You can trademark a color, but it's hard. It's very difficult.
Digressions, they're relevant. All right, so games, how do game engines work? Okay, we got off there because I was saying the Cougar Gold and Blue, and we were talking about, you know, RGB, which is how things are displayed in the monitor. If you print things, it's called CMYK. CMYK, I think that's right, which doesn't matter. I'm going to go down to the, oh, where's my picture? There it is. So all games do this. This is called a game loop. So the first thing that the game does is draw the screen. And then once it draws the screen, it waits for you to click or do something. If you click or do something, it updates the game. So like in Minecraft, you place a block. That's an event. The screen updates and shows that the block has been changed, and then it's drawn to the screen. And then it goes around and it handles another event. And then it updates the state of the game. Notice the game state is separate from drawing the screen. So it's like the game is stored back here. The screen gets updated after you change the game. So they're separated. There's a reason for that. So that you can do something called blit, which means that you take this whole thing, paste it all at once. So they're separated. But that is how, oh, Pong does not have a capital O in it. This is what monitors look like. They're square. The pixels are square. And so how do you make something look like something? Well, you have more than 8 pixels on the screen, right? So when you get bunches of pixels, your eye fills in the little gaps in the squares, and it makes it look like it's actually nice and rounded and everything is beautiful. But what happens if you zoom in? Well, this looks really good, but no, I'm not quite got far enough in this. So you can't quite see the pixelation. But if you get close enough, you've probably seen images when you get close enough, it pixelates. See this, you can just see it start happening now. It's starting to mudge just a little bit. That's called pixelating because the little pixels are now being identified separately and you can see the jagged pieces to it. But there's also something called anti-aliasing, which helps to prevent that, which we don't need to know about that right now. So we have all these pixels and the game state, or so to speak, is stored here. All those pixels are painted on all at once onto the screen. And it does it however many times a second you decide the game speed wants to be. And this uses the Cartesian coordinate system, which all of you math heads should know what that means. So 0, 0, 0, 1, 0, 2, all that kind of stuff. And we'd already talked about RGB. Oh, here's an RGB color picker. I should put that where you can find it. So how does animation work? Well, we aren't doing animation yet, so don't worry about that. We're just going to draw something to the screen. That's enough work. So we have initialized the game engine. It's waiting for things to happen. So it's running all the time in the background, waiting, 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 waiting. Well, we need a surface to draw things on. So I used constants to say that that's the width, that's the height, and now PyGame knows to set its game area to 858 by 525. I also wanted a caption so I could see that it is the Pong game. And then I need a clock. Why do I need a clock? So I can control how fast the game goes. Events, remember events? The game is always running, waiting for an event. Click your mouse, press a key, whatever you're doing, it's waiting for that event. It's an event-oriented program. Well, all I'm going to do is capture the quit event, and if I press a key. If I had to listen for everything, that would be a lot more listening than I need to do. So typically you just listen for what you want. It helps optimize the game for slower computers. So it's an optimization. Here we are. the famous infinite game loop, right? It is. Every game has a game loop in it that's running all the time. So my game loop is going vroom, 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 vroom. And each time it goes through the loop, I'm listening for any of the events. Now, pygame.event.get means it's listening for this event or this event. If either of those occur, if I see pygame.quit, I'm going to quit the game. So I'm looking at that particular event type. And this is a built-in event type that PyGame knows about. It knows what the quit event is. Well, I'm filling the surface, but am I really filling the display? No, the surface is back here. That's what you could, it's also called a back buffer, meaning it's like off to the side of your screen. So it draws it over here first, and then it takes that whole thing and goes into video memory all at once. So you don't see any flickering or as things are being drawn, it just goes, whoop, it's on there. So this part puts it over here. There's several different ways you can do this. Update basically updates only the things that have been changed. So it's an optimum way of blitting things over there. And how many frames per second are we going? 60. This is a simple game, so it can run 60 frames per second. Most movies run at 29.97. So 30 would be movie speed, like what you see on TV. Yes.
Oh, I have a question. So, like, in gaming, like the higher the FPS, like the better it is. Like some monitors are 120, 144, 165.
That's how often it refreshes the screen.
Okay, because I was gonna say
Frames
like,
per second is not quite the same thing.
oh,
Frames per second is how often is the frame redrawn. So the higher refresh rate on your monitor means that you can see the changes more quickly. I think that's a good way to say it.
yeah.
What do you think, Francisco, Benjamin?
Hmm.
Yeah, you would agree, right?
Yeah.
Okay, you guys both flunked the class then, so
Okay, I see. Because I haven't really
I'm
gotten
kidding.
into like video. Someone's been coding up the video side, so I wouldn't know. Like, I didn't really know the difference.
Yeah, refresh is how quickly this will refresh as you're displaying things to it. This is how often we draw a frame. So
Right.
every second we draw 30 frames. Because it's like an animation. Well, I can show you just by doing this. Look at there, how much animation do we have? None. So it's still redrawing at 30 frames per second, but nothing's changing. So it's not really doing anything right now because I have the update method, which only makes a change if something changes. That's the only time it makes a difference. Now, if I go to newer versions of this and I slow it down, then you can see the animation going on. What was I doing? Pong. Let's go to the one where we're actually bouncing the ball. That'd be a good one. Do I draw the ball? Oh, I have several files in there, so I have to open the Pong tutorial like this. And then we'll slow it down. Yeah, bounce ball is good. All right, let's bounce the ball. There we go. So it should be running at 60 frames per second. Getting a little lag on this computer, why do you suppose? It's got a onboard video card that doesn't have much video RAM, so you're gonna see little bliggles on this thing. At home, I don't see anything like that. It's perfectly smooth, but these are not gaming computers. So how does that work? Well, let's slow down the frames per second and see what's actually going on. It's like animating a cartoon. It's like a movie. Let me find I should have done it as a constant, shouldn't I? So we'll do it at 5 frames per second. So movies have, there, that's how you do animation. It's redrawing, moving, redrawing, moving, redrawing, moving, redrawing. It's exactly what you see every time you look at a video game or you look at a TV screen, watching a movie. YouTube doesn't matter. It's all little tiny pieces moving just a little bit, but it goes fast enough that your eye can't see that there's little things in there. And your eye stitches it together anyway, because most of your eyesight happens where? Most of what you see is processed over here. Yeah. 80 or something percent of what you see is made up by your brain. It's assuming lots of things, it's filling in details automatically based on what it remembers. Otherwise, your brain would explode because it's too much to process. All the input that our body gets is way too much for us to process. So we take shortcuts by just using simple analogies for what's going on. That's not the right explanation. We think we're seeing everything in real time, but we're not. We're making a lot of assumptions. We're using things to block out information that we don't need. Otherwise, we'd overwhelm and we'd be like autistic people don't have those same kind of filters. So they get overwhelmed very quickly. We have better filters so we can operate and function. But that's how it works. So this little guy is moving up 1 pixel to the right 1 pixel, up 1 pixel to the right 1 pixel. And that's what it's doing the whole time. Every game you play does the same thing. It's called frame animation. And they all work like that because movies do.